Hi, and welcome to a session of how to make a Connect4 game using Python and Pygame. My name is Scott Bartow, and this tutorial is offered to you by the Clifton Park Half-Moon Library. So today we're going to be using Python, but we're also going to be using Pygame, which is sort of like a game development component to Python. And we're also going to be importing a couple other modules besides Pygame. So if you've downloaded Python to your computer, Python will come with the two screens that you can see on my screen. On the right is the Python shell. On the left is the idle text editor of Python. So those components are downloaded once you download Python, and you can go to python.org to download Python. Also, what's included with Python when you download it is something called PIP, and PIP can be used to download different components of Python. And for this exercise, you're going to be needing the following components. You're going to need Pygame, Pygame. You're going to need Numpy, Numpy. You're going to need sys, sys, and you're going to need to download or install math. So the way to do that is to go into your command line. Once you have Python installed on your computer, downloaded to your computer, you want to go to the command line, and then from command line you would type in pip space install space, and then the different components that you're trying to install. So I can do it on the Python shell. So you would type in the command line, you would type pip install, and then you would type in Pygame, or you would type in, and you would run that. You would hit enter, run it, have it installed on your computer, and then you would do pip space install space sys, hit enter, install on your computer, and you would do pip install math, hit enter, and that will install all these libraries onto your computer that you'll be able to use with Python. So let's see. If you look off to the left in my idle session, I have the program all done, and so if I run this program, so in idle, if I do run, I just want to show you what the finished product is supposed to look like. So I do run module, and in the Python shell, it's going to show the game, and then it brings up the Pygame window, which is a whole lot nicer looking. So if you look in the Python shell, slightly to the left, this is the game in command line format. We're going to create a game in the Pygame window. We're going to create a game with a black background or blue game setup, and then we'll have a red circle for the player number 1 and yellow circle for player number 2. So the way this game will be played is you can see I can move the red ball left to right, and once I click on it, once I hover over a column and click on it, it will, there we go. So yellow goes first, so click on it and yellow went down. And now if I click on red, I can hover it right over the yellow if I wanted to. All right, so now yellow is available. And if you look at the Python shell to the left, you can see that let me just go down a little bit. I'll move the game up a little bit. There we go. I was missing a row on the bottom. You can see each time I click on one of the circles, whether it's red or yellow, red is given a number of 1 and yellow is given a number of 2. So on the Python shell format of the game, every time so if you look up here on the first part, let's see. So this is how the game came in when we opened up the program. And then here's the first move. And a 1 went down to column number 4 and down to the bottom row. And then the yellow, second move, the yellow, which has is symbolized by number 2, went down to the same column, column 4, and is placed here above the 1. And then the third move is for the red circle, which is symbolized by a 1. And you can see the 1 went right here over the 2. So I have 1, 2, 1. All right, so that's how it's displayed in the Python shell. And this is what the game is going to look like. All right, very similar to a Connect 4, a physical Connect 4 game. All right, so let's get started. I'm going to close out this Pygame window. Close it out. I'll close out the Python shell. All right, and what we're going to do is we're going to close this out. We are going to open up a brand new idle session. So in the Python shell, you do File, New File, and you can see it's untitled because we haven't saved the file under a certain file name. All right, so this will be our idle session with a brand new program, our Connect 4 program. And I'm just going to make this screen not so wide so we can see the Python shell as we run it. All right, so let's get started. And first we want to do is we want to import those modules I was talking about. So we're going to do import. I'm going to do a comment. I'm going to say connect 4. And comments in Python, you use the hashtag before the comment. So Connect 4 game in Python. How about Pygame? All right, so the first we want to do is we want to import those libraries that I spoke about earlier. So import Pygame, hit enter, and let's do import Numpy as NP. So NP is a alias name for the library Numpy, so it just shortens it a little bit. So we'll be whenever we're referring to the library Numpy in this program, we're going to use the alias name of NP. And then we'll do import sys, and lastly, import math. So these are all the libraries you were supposed to install on your computer using pip space install space and then the library name. All right, so let's see. So let's do a few variable names. All right, so I'm going to capitalize these. These are going to be constants. So blue. All right, so create the variable name blue equals, and then we're going to do we're going to give it the RGB value, which is 3 values in parentheses, to give it the color blue. Right? You can do the way you name colors you should name them just with the color name, like blue. Or you should name them with the hash value, which is hashtag, and then 5 alphanumeric characters. And then finally, you have RGB, which is, I'll show you with the variable blue, we're going to do RGB equals parentheses 0, 0, 255, parentheses. And so now when I reference this variable name of capital blue, it will be the color blue using the RGB code. All right, so now we have, so blue is, remember, is the frame of the game. And then black is the background color behind the frame of the game. So black equals 0, 0, 0. All right, that's the code for black. And then we have 2 more variables. We have red, which is the circle or ball that, or checker. Now, but checker is probably a better word for it. That is represented by player. It's the choice represented by player number 1. All right, so let's do red, which is parentheses 255, 0, 0. And finally, we have yellow, which represents the choice of player number 2. And this is going to be 255, 255, 0. All right. So now we have our 4 color variables, right? One for the frame of the game, blue. One for the background, which is black. One for the player's choice, number 1, player's choice. The first player number 1's choice, which is red, and player number 2's choice, which is yellow. All right. So we have all those variables set. Now we have a couple other constants for our game. Our game is going to be set up where you have 6 rows going across. So we have 6, you have row count. And I'll put that in capitalized. I'll capitalize the letters in this variable name. Remember in Python, the variable names have to start with a letter, and they can only include letters, numbers, and the underscore special character. No other special characters are allowed. And so we're going to have 6 rows across our game, and we're going to have 7 columns. Column count equals 7. All right, so we're all set. Now, let's see. What do we want? All right. So let's set up our board. All right. So we'll do we're going to create a function. Here's where we're going to use Numpy. So create a function, and in Python, function is created with def for define. So def, and then we're going to call the function create underscore board. Let's see. And then a colon, hit enter, and indents. And we'll create a variable named board. And that is going to equal np, the alias name for Numpy library, dot zeros. And we're going to do 6 rows of 7 columns. Hit enter. And then in our function, we'll return board. Hit enter, we get out of our function. And then we'll say board equals create underscore board. Oops. Underscore board. Parentheses. And we should be all set. Here on the scoreboard. And then I'm going to do a print, Python print forward. Let's see how it looks in the Python shell. So it should have 6 zeros going across for rows and 7 zeros for columns. All right. So what I'll do is we're going to save the file for the first time. So up in the toolbar in your idle session in your test editor, click on Run, and then the third option down, Run Module. Click OK to save it, and then find a place, find a folder that you want to save this to. Mine is this library right here. Make it connect for a game using Python and Pygame. And under the file name, I'm going to call this connect for.py. All Python programs end in .py. py for Python. Click save, and in the Python shell, off to the right of my screen, I have an error. Data type not understood. All right, so let me try and figure this out. MP.zeros. Oh, I see. So I'm supposed to have 2 parentheses here, 2 opening parentheses, closing parentheses. All right, so I'll do run module again. Click OK. It's already been saved. It'll save it again for the previous file, and there we go. So you can see our board is laid out this way, right? So we have 1, 2, 3, 4, 5, 6, 7. We have 7 zeros for columns, and we have 1, 2, 3, 4, 5, 6 zeros for rows, right? Okay, so and now I can just comment out this print. We no longer need it, right? We just wanted to use it for. So we have our board created, and what we're going to do now is we're going to create a variable called game over, and that's going to equal to the Boolean false. And false is spelled in Python is spelled with a capital F. All right, so that's our game over variable. And then we're also going to have a turn variable. So turn equals, it's going to be initialized to 0. All right. And that's what we want to do is we're going to use the Python while. So while not game over. So while not false. Then I'm going to, and the game will be over. The game over variable will be set to true once we have 4 in a row. Once one player has 4 in a row. So they win the game, so the game would be over. So while not game over, so while not false, I want to ask the player number 1. I'll put a comment in here and say ask for player 1 input. All right, so if turn equal 0. Remember, with conditionals, you have to do equals and end it with a with a colon. Then I'll say I'll create the variable selection equals int. So I want to convert this whenever you well, I'll show you. Whenever you use the input command, right? You're asking for user input. You do input parenthesis and then double quotes player 1. Make your selection. And I'll tell them do 0 through 6. 0-6. All right. Semicolon, and there we have that. Okay. Oh, I have to close it out with the double quotes. Quotes. Yeah, there we go. And then I'm going to have 2 closing parentheses. I'm going to make my idle screen a little bit bigger. Okay. So selection equals input, player 1, make your selection, 0 through 6. And the reason why it's 0 through 6 is that we're dealing with an index, and the index starts at 0, right? So you enter 0, 1, 2, 3, 4, 5, 6. That's a total of 7. So remember, our game board has 7 columns. All right, but when you use the input statement in Python, what you're doing is you're returning a string, and we need to return a number, 0 through 6. So what we'll do is we'll convert this by using int, the int method, which will convert a string into an integer. Integer is just a whole number. All right, and that should be good. Now, we're going to want to have an else statement here. So else colon, it entered automatically indents, and then here we'll say, so if turns not equal 0, then selection 1 would go. Or if it's not equal to 0, then we'll hit their else exception, and we'll say selection equals int input quotes, and we'll say player to make your selection 0-6 parenthesis colon double quotes, and then 1, 2, 3 closing parentheses. And all right, so that should be it. Our game's not over. All right. So now we're asking for player 1's input, and then on a rotational basis, we'll ask for player 2's. So what we're doing is we're initializing the variable turn up here to 0, right? So it'll be 0 to start. When we come in, and in our while loop, when we have the first turn come up, if turn equals 0, right? Then we'll have the selection be for player 1. But what we need is we need to increment turn whether either condition hits. We need turn to be incremented by 1. So we have plus equals 1. All right, and then we also want to take the mod of turn. So we'll increment turn by 1, but we're going to use the Dallas, so which is the %sign space, and we're going to divide by 2 and take the remainder. And that way it will rotate around between player number 1's turn and player number 2's turn. All right, so now that that's set in our while loop, and why don't we go up to the toolbar and do a run module, and let's see how the game is looking. Okay, invalid syntax. All right, so I got an error, invalid syntax, and it shows up here for the input statement for player number 1, and it turns it red for the last closing parenthesis, and I can see why. I have 1 too many. Right, so I have an opening parenthesis here, opening parenthesis here, opening parenthesis here. I have it 1, 2, 3 closing 1, so I don't need the third one. And I also don't need the third one for player number 2. So now I took that closing parenthesis out, and I'll do run module. Let's see if this works. And it's running, and can't tell if it's working. All right, let's open this up. So I ran the program, and I had modified the program. So if you look off to the left, you can see turn equals, and I had %2, but it's got to be turn equals turn %2. So whatever the value of turn is at this point, you're dividing by 2 and taking the remainder, and the remainder determines if it's odd or even. If it's player, you're going to be player number 1, or if it's going to be player number 2. That does the selecting. So let's see. And so when I run this, you can see in the Python shell, it brings up the input question, player 1, make your selection. All right, so I'm just going to choose a number between 0 and 6. So I'll do 2. Now I just want to test to make sure it's rotating between player number 1 and number 2. So it says player 2, make your selection. So whatever I choose between 0 and 6, I'll choose 4. Now it's back to player number 1. I'll choose 4 again. Now it's player number 2. So we know this logic is working. Our while loop is working correctly. Now let me just make my idle session a little bit bigger. So one thing with our program, the way it's set up right now, is we have to be able to flip the orientation of our game, because and there's a command in Numpy that allows us to flip the orientation over. We want the orientation to be in the upper left-hand corner, and without flipping it, the orientation is going to be in the lower left-hand corner. So every time a player makes their choice, the board is going to be marked from the top first. And we want just like in a real Connect 4 game, we want, when you put the checker in, we want it to mark the slot that's on the bottom of the board. So what we'll do to flip things over is that we're going to create a function, and we'll do that up here. All right, so we have these things. All right, so we're going to create a function called we'll call it def, and we'll call it print _ board, and we're going to pass in board. Flip it around, follow with the colon, and what we'll do is we'll print. And remember, alias name for Numpy is np. So np dot, and then we'll do the method flip, and we'll flip in the board, comma 0. Right, we have to tell it what orientation we want, and that'll be it for for our method or function that we're creating. I'm going to move this below the previous function we had. All right. And what we'll do instead of printing the board, now we're going to call our function. So we're going to do print board. So by calling the function, you use the function's name, print board, and we're passing in board. Right. Okay. So now we want to start creating a few other functions. And so we're going to create, so we have our create board, right? And so we got a create board up here. And we're going to create a function drop underscore piece. And what we'll be passing in there is board, comma row, comma col, comma piece. Let's see, and colon. And since the selection is really what you're choosing, player one is choosing between 0 and 6 is the column index number. So let's change selection to col for column, because that makes a little more sense. All right, so I'm going to use the col variable name as the player one or player two input. All right, so that's one of the parameters that I'm using when I'm creating this drop piece function. I'm using col. All right, so hit enter, and for now I'll just say pass. And another couple of functions I want to create is def is underscore valid underscore location. Like, is that the player's choice? Is it a valid location? Like, is that slot all filled up, or is it available for the player to choose? And the parameters I'm going to be passing are board and col. Enter, and I'll do a pass here, just temporarily. And the next function that I want to create is get next open row. And the parameters I'll pass are board and col. Okay, so I'll just do pass for now. Okay, so first let's work on, is it a valid location? All right, so I'll take out pass, and what I'm going to do is I'm going to return board, and I'll do the index 5, right? Because with rows, rows are 0 through 5, right? We have 6 rows altogether. You start the index at 0. So we have 0, 1, 2, 3, 4, 5. 0, 1, 2, 3, 4, 5, which is 6 rows altogether. So I'm passing row number 5, which is the top row. And that just checks to see, well, is the top available? And I'm also going to pass the index, whatever col is, whatever the user's choice was. Sorry. Get rid of that. And so this would be the variable col, the column that was chosen by the player. And whenever this is equal to 0, oops, just equal to, I'm assigning 0, or I'm checking to see if it's 0. Whenever that's 0, that's what it's going to return, that this is, since there's a 0 in that slot, that means it's available for the player to choose. All right. So that's it for isValidLocation function. Now let's work on the getNextOpenRow function. All right, here we're passing the parameters board and col. And we're going to do a for loop here. So for, and we'll just say R, representing the row. R in range. And remember up above, top of our program, we created a couple of constant programs, or constant variables, row underscore count and column underscore count. So here we're going to be doing a loop based on the row count, which is 6. So I'm going to use a variable that we set up above, a global variable, and colon after the for loop, and indented inside the for loop, we're going to have an if. So if board, bracket R, bracket call, bracket equals 0, or equals, because we're dealing with a conditional here, 0, colon, and then indent inside the if, I'm just going to return R. So whatever R is. Remember, in the for loop in Python, R is the temporary variable, which is hitting set. And we're looping around whatever the row count is, which is has a constant value of 6, right? We have 6 rows in our game. If the board with row, whatever this is going to be 0, 1. Each time we loop, it'll start, R will have a value of 0 to start the first loop, then a value of 1, then 2, 3, 4, and 5. So whatever the row is and whatever the col is that the user selected, if it equals 0, then you're going to return R, that is an available row. All right, and then the last function we have to work on is the drop piece function. And here we are going to indent, and we'll have board, and then we'll have a bracket, row, bracket, oops, bracket, row, bracket col, bracket equals piece. All right, row, and yeah, that should be it for these functions, right? Create board, drop piece, isValidLocation, getNextOpenRow, and we also have a print board to flip the orientation of where our 0, 0 index is. And yeah, that should be good. All right, so we have our function set up, and I'll get rid of a couple of lines here. All right, so in our while loop, when we're looking at the condition for player number 1, indented in our if statement, we're going to create another if. So if is valid location parenthesis, and then we'll do board, and we'll paste the col, colon, and enter, and then inside the if, we're going to have row equals get next, we're calling our other function, get next open row, open and row, and we're going to pass into get next open row the arguments board, col, column, hit enter, and then we're also going to call our function drop piece. And this is passing the arguments board, row, and 1, because we're dealing with player number 1. So we're going to give that value. Right. Enter. Huh. I must have accidentally erased the else statement. So I was going to copy all this code for player number 2, but what I'll do is I'll copy all this up above 2. So I'll copy it, paste it, and remember early on we had a paste it here, and this should just be else. Right, else colon, and col equals int input player number 2. Right, and that should be that column. And then if location, also all this code that we just added, calling the different functions, is valid location, get next open row, drop piece. The only thing we have to change for player number 2 is this value right here. Instead of a 1, we want a 2. And that should be it. We should be ready to try and run this now. So if you go up to the toolbar, run module. And let's say I am going to wipe out the Python shell, and I will start with a fresh session. So run module, and then I should bring up my Python shell. There it is. It's going to ask me player number 1, make your selection. So I'm going to say 3. Still not showing up. All right, so there's still something wrong. Let's see. So let's run our program and see if our pieces are dropping into place. Run module, start with a fresh session. Okay, you see the board. The board asks for player number 1 selection, so I will choose 3. Oh, not legendary. Hold on. All right, I had to break out of this. All right, so let's run module again. All right, and there's our board. So I'll do 3. And you see player number 1 is represented by a number 1. Goes to the 3 column spot. And so remember, the first column has an index of 0, then 1, then 2, and then 3. So if you go down, you see 1 was placed at the very bottom of column 3, which is the column on the board. It's column 4. Then I'll do a 3, and then now they place a 2 in the row above the number 1, and then I'll do a 3, and see we have 1, 2, 1. All right, so this is all working. Close that out, and let's get back to our program, because now we have to check for to see when the player wins. All right, so We're going to add another function up above, right? And so what we'll do here is we're going to create a function def, and we're going to call it winning move, right? And give that a little space. So the winning move, let's get it. We're going to pass the parameters board, comma, and what else? Piece, comma, colon, hit enter, and then inside. So we're going to have a couple of ways to win. We're going to have horizontally, vertically, and diagonally. So I'll just put a comment here. The first one we're going to check for is a horizontal win. So check horizontal rotations for win. All right, and we'll do a for loop for C in range. Do column count minus 3 colon. And if this happens, we're going to do if. Okay, so if. So for the function winning move, right, we're passing in the parameters board and piece, and what we're doing, what I've done due to the shortage of time, is I've created the four scenarios where a player can win. You can have 4 horizontally, 4 in a row vertically, 4 positively diagonal, and for negatively diagonally sloped. And so that's the code I've entered in using a for loop, and then a for loop nested inside that loop, and then an if conditional. And I'm returning true if that's the case. And let's say, okay, so you can see I'm checking horizontally, I'm checking vertically here with this code, I'm checking positively, slope diagonally, and negatively slope diagonally. So those are the 4 scenarios for a win. And now I have to call this function winning move, winning underscore move, down below here. So this will be done inside the if for player number 1. And I'll say if winning, so I'm calling the function winning move, and to say, and I'm passing the arguments board, comma, 1. 1 represents player number 1. So if that's the case, then what I want to do inside the conditional is I want to print quotes capitals player 1 wins. Congrats. And then I'll close that. Print out. Oops. Close this out. And I also want to have the game end. So remember in the beginning of the program, well, we're doing this while loop right up here. We had set the game underscore over variable to false. We're doing this while not game over. So while game over is equal to true. But now that I have a winner, I want to set the variable game underscore over equal to capital T true, capital T true. All right, oops. And that should be it. And that should end our game. Well, not game over. Well, not game over. Okay. All right, and I can copy this code. And oops. Oh, yeah. I want to copy this and put it down under this else for player number 2. It has to be indented. Yeah, that's good. And I also want to change the print to say player 2 wins, regrets. And then I want the game to be over by assigning game_over variable to true. All right, let's run it and see what happens. Functions use tabs. Okay, it doesn't like my tabs here. And it's right here for that in range. All right, so let's see what the problem is.
Then we're going to return true. So we want to return true the first time this happens. We're not going to return this expression because that would break out of this loop before we wanted it to. Okay, and so what we're command-line version of the game. So we're going to take this game and we're going to expand on it to actually make it look nice. So the first thing we're going to do that is import a library called Pygame. And just like the Numpy library, if you don't have Pygame installed, just open up a new terminal window and type in pip install Pygame. As you can see, I already have it. Cool. All right, and now what we're going to do is we're going to have to start out by initializing Pygame. So this you have to do in any Pygame project. So before our game loop starts, we're going to do pygame.init. Okay, and then what we're going to have to do is define our screen size, how big we want our game to be. So if I real quick just build the finished version I have, you can see that, it's pretty, you can kind of break this game down into squares, I would say. You have squares that represent each column and each row, and then I have this one extra row at the top. So we're going to define each one of those squares as 100 pixels. So the sizes we're going to talk about right now are all in pixels. So the square size is going to be 100 pixels, and then our width for our screen is going to be the number of columns, so the column count, times the square size. Cool. And the height is going to be the row count times the square size. And actually, if you saw the game I just dragged in, I'll drag it in one more time. I actually added one additional row because I wanted the spot where I could display this circle that I'm dropping. So we'll actually make this row count plus 1 times square size for the height. And that will be packaged together nicely in a variable called size, which will be a tuple of width comma height. And then to get Pygame to actually read that, we need to type in the following: screen equals pygame.display.set mode, and then we'll have it read in the size. And if you're wondering where I'm kind of just magically getting these functions from, I'm looking at the documentation on the Pygame site. So if you go to pygame.org/docs, you can find all the kind of functions that I'm using. I'll post a link to that in the description. And we're going to real quick test to see our screen is actually working. So you can just run Control-B. As you can see, the window popped up and then it disappeared. We'll handle why it's disappearing in a second. So it looked like though it is reading in that screen. Cool. So let's now create a function called, we're going to do a couple things. So I think first we'll define a function called Drawboard. And this will just be like printboard that we defined up here. But now we're actually going to draw it with the Pygame graphics. So Drawboard is going to have to take in the board, and that's about it. And I'll actually pass this for now because we're going to make some changes to our loop before we do this Drawboard. So the first major change we're going to have to do to our loop is Pygame is an event-based game library. So Pygame kind of works and allows you to function in the game by just reading all of your movements of your, the keys you press, the mouse buttons you click, the mouse, like how you move your mouse. It reads those all in as individual events. So that looks like something like this. So for event in pygame.event.get, and as I just said, events are like mouse motion, mouse button down, key down, etc. So we're going to drop a piece by clicking down. So that's one of the important events we'll have to get. So we're going to first do, just kind of follow me on this one, event type, if event type equals pygame.quit. So this is just something you want to handle in all of your games that you make, just allowing your game to properly exit out if you click the button here in the top right that X's out of it. So if that happens, we have to do a system exit just so it properly shuts down. And to get this sys right here, we're going to have to import that into our project as well. That means system, and that comes default in any Python installation. Okay, system exit. Now to get to the more interesting stuff, the event that we really are going to care about to start is mouse button down. So if event.type equals Pygame.mouse button down, and all the different events you can also find on the Pygame website under the docs. The game is going to run by us clicking down on a specific spot on the screen where we want to drop the piece. So instead of reading in the column we want to drop it in, as we did previously, now this column is going to be populated by where we click. So I'm going to real quick put all of this stuff, all of this behavior into this mouse button down event type, because now the events of us dropping the piece always happen when we click the mouse button down. So we don't want it to happen otherwise. We don't want it to be asking for this input. All right, so column equals, and this is going to be where we click on the screen. So just for now, I'm going to just kind of comment out this stuff, just so it doesn't run on us while we're testing. And let's just real quick see if this fixed our error of the screen disappearing right when it pops up. What happened? As you can see, now we have the screen and it's not, it's staying here. So that's because we actually added in this event loop here. It knows to kind of continue while these events are happening. And the exit out will be handled properly by this, the system exit. Cool. All right, so we have our screen looking pretty good, but doesn't have any graphics, obviously. So we're going to implement the drawboard function now. So if we think about it, I'll drag in the finish one I have again. We're going to draw some sort of rectangle for each of these slots, and then a black circle inside those rectangles. And then we'll have to draw this afterwards, this piece that we dropped. And then whenever we do drop a piece, the one or two that's in our command line based game will become like a red circle or a yellow circle based on what we're doing. So let's implement this. So first, we're going to iterate through kind of every spot in our board. So for R, or for, we'll say C in range column count. Then we'll do the same thing for R in range row count, just as we did above here when we're iterating through all the spots. Well, we need to initially just draw it as like an open, a blue rectangle, and then in that blue rectangle, we want a black circle. So we're going to do a Pygame.draw function. So first we're going to draw a blue rectangle. So that looks like kind of our game board. And then the black circle is
So looking at the 4 ways to win, I want to break down the code that we were using to create the function winning_move. So we're passing the parameters board and piece into the function. And so let's take a look at the first way to win. The first way to win is with 4 sequential pieces for either player 1 or player 2 that are going horizontally across. So it's within a row of the game board. So what we've done here, just put a comment in, say horizontal rotations for the win, and we're saying for C, we're using a for loop in Python. So for C in range, And we're looking at the column count minus 3. And let me run this and I can show you why. So column count minus 3. So if I do run module, and it brings up our game board. And so, so what we're talking about is 4 cross for either player 1 or player 2 for them to get the win. So it's we're looking at the row of the board because we're dealing with a horizontal win. So the row can start. It can start here, or the column can start here, which is index of 0, index of 1, index of 2, index of 3. But it cannot start here, index of 4, because you wouldn't have 4 across. So we only have to deal with index 1, 0, 1, 2, and 3. So going back to our code, you can see, so we're looking at the column in range, column count minus 3, right? Because the column count is 7. So 7 minus 3 gives us the first 4 columns where this series of 4 can start. I don't know if that makes sense, but and then within that loop, we're looking at the row R, the range count of row. So it can be any of the rows because we're going horizontally across. So so if board RC equals piece and board RC plus 1 column equals piece and 2 column and 3 column, if that's, then you want to return true that there's been a win. So winning move would return true, which means that person won. All right. Now let's move on to checking a vertical win location, or a vertical location win. Now here with the vertical location, we're saying for C, it's representing the column, in range column count. Now column count is 7. And because we're going vertically, so now we're dealing with the rows instead of the columns. When we're doing horizontal, we're dealing with columns, 4 columns being selected sequentially, and with the vertical location when we're dealing with the rows. So for R in range, row count minus 3, right? Because you can only have, here, let me show you the board again. All right, so now we're dealing with a win vertically. So so if we start at the bottom, right, the bottom has index 0, 1, 2, 3, 4, and 5. You can have a vertical win. You can start here, and start here. But that's it. You can't start here because you only have 3 in a row instead of 4. So going back to our program, so for a vertical win, that's why we have row count minus 3. And then next we have we're checking a positively sloped diagonal. So we're going up. I'll show you the board. Say we started down here in the bottom left. Then the next one would be this one, and then this one, and then this one. Now, you can only have, this can only occur in certain rows, certain columns also. So like if you started with this row and you were going up diagonally, you know that in this row you can't do it because there's only 1, 2, and 3. So you can only start it in this row, or this row. 1, 2, 3, 4. So that's what we have in our code. And we are looking at the row count -3 once again. And then when you're doing negatively sloped, you're going to have the column count -3. So I know it's a little bit complicated checking for all these different possibilities for a win for each player. And you also have to take into account that you have 2 different players going and competing against each other. So that's what we put into our function called winning_move. And then in our while loop, so first we're dealing with player number 1. And I'm going to put a comment down here above the else to just let you know that we are working on player number 2 selection, player 2 input. All right. So if you look at player number 1, down here we added this if. So if, and then we're calling winning_move, calling the function. We're passing the parameters, the board, and we're also passing the, not the parameter, but the argument board and 1 to represent player number 1. And if that function returns true, then we're going to print player wins, congrats, and we'll say we'll set game over variable to true, which will end us out of this while loop because we're doing while not game over. All right. And then we do the same thing for player number 2 down here, except we what we're printing out is we're printing out player 2 wins, congrats. All right. Board. And one thing we did have to do in this player number 2 conditional, so we're calling if winning_move, we call the function, we pass the board, and we're passing 2 down here instead of 1. Sorry, I keep dropping my mouse. All right, so let's play this game. Save these changes, and our board comes up. All right, so I've already tested for player number 1 to win, but now I want to test that player number 2 wins. All right, so why don't I try and do a vertical win? All right, so player number 1 is going to go first, and he's going to select 6. Enter. All right, and 1 shows up here in the bottom right hand corner. All right, so now, oops, I'm going to have him select 0. I'm gonna restart this game. So I'll close this out. I'll run it again. And okay, in the Python shell, it comes up, and we have our game board. All right, so for player 1, I'm going to choose 6, and 1 shows up. For player 2, I'm going to choose 0. And player 1, I'll choose 6 again. Player 2, I'll choose 0. Player 1, I'm going to choose 5 this time. Player 2, I'll choose 0. And player 1, I'll choose 4. And player 2, 0. And I should have a win, a vertical win for player 2 here. Oh, message player 2 wins, congrats. And the game ends. If I hit enter again, you can see the game is ended. All right, because in the Python shell, when you see the 3 greater than signs, that means you're back to the prompt and you're not running your program any longer. All right, so we tested the horizontal win for player 1, the vertical win for player 2. Now let's test one of the vertical wins. All right, so I'll close this out. I'll run my program again. All right, let's see if player 1 can win vertically. The game board comes up, and I will choose. I'll choose 0, and then I'll choose 1 for player 2. I'll choose 1 player 1, and I'll choose 2 player 2, 2 for player 1. Oh, 2 for player 1. Oh yeah, that's right. And then I'll choose 3 for player 2, and I'll choose 2 for player 1, and I'll choose 6 for player 2, and I'll choose 3 for player 1, and 3 for player 2, and 3 for player 1, and player 1 wins. And you can see, starting in the lower left-hand corner, I have 1, and then diagonally going up, I have 4 ones in a row, and positively sloped diagonal. All right, so unfortunately, I ran out of time showing you all about how to create this game in Pygame. So I was only able to run it using Python. Pygame is a lot more attractive visually. That's why it's used for gaming. And I'll just have to save that for another lesson. But thank you for joining me, and I hope you've enjoyed this tutorial. Once again, my name is Scott Bartow. This has been Making a Connect for a Game using Python, and it's been offered to you by the Clifton Park Half Moon Library. Thanks again for joining me.